what we could come up with. I think this should be fine. I'm going to run this. You can see the output. It tells me view task, add a task, complete a task, delete a task. What is actually displaying this at this point is the display menu, and at the same time my load task is running. So I'm going to run this and I'm going to choose to add a task. I'm going to say to add a new task, subscribe to Data with David. Hello guys, welcome to my YouTube channel. Well, today's day 15, the final day of our 15 days of Python series. It's been an incredible journey. We've started from day one where we started with the very basics of Python, and we took it gradually and increased the heat step by step, and today we are going to be hitting the final hit of it. Today's an interesting one because we'll not be doing much learning. Of course, I'll be learning along the way, but we'll be working on the project. In fact, 2 projects. I thought of having 2 projects because I know that some people watching this video might just want to be developers. They just want to learn Python and use Python in their development work, building of websites, creating software application, creating app, phone app, and all of that. And another group might just be data scientists, data engineers that want to use Python to scale up their data analysis, data transformation project and work. And I thought to myself, well, to cater for different groups of people, of course, I might not cover everyone because there are different use cases for Python. We're going to be working on 2 projects. One, we'll be building like a simple app and we'll not be deploying it anywhere, just run it within our environment and just have an idea of how you could do development with Python. The second is going to be a data transformation work. Let's see what the task of a typical data engineer is. Extract data, transform data, and load into an output destination. Now, I'm going to be going over the project quickly. The first project is a simple to-do list application. And just to give you an overview of what the project is, the to-do list application is a command line tool for managing personal tasks, and users can add, complete, delete, and view tasks with all data stored in a JSON file for persistence. Everything will be done on JSON. I don't have any database I'm going to connect to because it's just a quick project. We're going to be doing everything within our environment, the IDE we'll be working with. This project covers the basics, CRUD operations, and will teach you how to structure small applications using functions and file handling. So all of the basics, starting from creating, reading, updating, deleting, you're going to learn everything using this particular project. The tools we'll be working with and the libraries, of course, we'll be writing this on Python, and we'll work with JSON file that's going to store our data, and we'll be using the OS operating system. We'll be doing the importing of the OS for file handling and checking off the paths that we're going to be storing the different files we'll be working with. You know what? Let's go to our environment and get started with the first project. I have this day 5. If you've not created day 5, please go ahead and create this directory. And I'm going to be creating an additional directory called to-do list app. In my to-do list app, I'm going to be creating the functions we'll be using for this app, and I'll be explaining this along the way. Let me call this to-do functions. Don't forget the purpose of the to-do list app. In the to-do list app, users can add a task, they can complete a task, they can delete a task, and they can also view the different tasks that we have. And we'll be creating functions in line with these requirements that we have. We're going to be creating the functions to add a task, but before then, let's import all of the packages that we'll be using. I'm going to import JSON, import OS, and next let's create, so this I'll call it add a new task. To create the function, this to add task, give the function a name, and within here I'm going to be taking 2 parameters. The first parameter is the actual task, and the second parameter is going to be the title of the task. So the task is going to be a list, and to add a new task, I'm going to be appending to the list, appending this dictionary, the title completed, false. So I'm going to be adding title, and I'm also going to be adding this. You tell us if this is completed or not, and if it's completed, it's going to turn to true. For now, it has not been completed, and we're going to set that as false. And after that, you're going to print that the task has been added. So when you add a task, it tells you that a particular task has been added. The next will be to load a task, like to view all of the tasks. I'm going to create a function for that, and I'm just going to add a title for it, load task from a file. I'm going to define the function. So to load tasks is just for me to view all of the tasks I have, and the task is going to look into the file where I kind of store all of the different tasks that I'm going to create. And typically this should be coming from a database, but we want to do everything within our environment here. So it's going to look through this place, and if it exists, it's going to read that file. And when it reads the file, it returns it. But if the file does not exist, it just returns an empty list. The next is, how do we now save the different tasks we enter into our JSON file? I'm going to be writing the code to save that. To start with, I'm first going to write the save task to file just to give it a title. I'll give the function a title, and I'm going to put in a parameter that is going to take the task, which is a list. So I'm going to save this list. And just to explain what this code is going to do, I'm going to be opening a JSON file with the JSON file with the write mode. If the file doesn't exist, this is going to create the file. There's a function within the JSON module, and this function is quite incredible, called the dump. What the dump would do is to put this in a JSON format, like a dictionary with a key value pair, and is going to write that into my file. And it's going to write this because I've created an alias or file for my task.json. It's going to write into this file. So each time I call the function to save the particular task that I've added, is going to do all of that, create a JSON file if it doesn't exist. If one exists, it's just going to write into that file and does that using the dump. The next, I'm going to create to display the task. Create the function, define the display. I'm going to call it display task, and it's going to take in a parameter called task. Now I'm going to put a condition because this is to display all of the tasks that I have. If the task does not exist, what should happen is to just display no task available. If the task exists, what is going to happen is going to perform a loop for each of the index and the tasks in this. So this enumerate function is creating an index for each of the tasks that I've created already. And the status is going to be good if the task is completed. If the task is not completed, it's going to be an X. And I'm going to print the index, I'm going to print the task, and I'm going to print the status of the task. The difference between this and the load task is that this is going to run once I run my program. I'm going to orchestrate all of this in a different file called the main.py. This is going to load up when I run the file, when I just open the file for the first time, but this is when I want to view the individual task, the index of the task, the title, and the status of the task. Is this completed or is this still ongoing? The next one I'm going to create is, how do I complete a task? I'll call this complete a task. To complete a task, I'm going to create a function called complete task, use underscore. I'm taking in two parameters. I'm going to take the task, and I'm going to take the task number. For this, I'm just going to create like a condition, so we'll be on the safe side, and want to ensure that the task number, the number we're going to have from the task, is greater than 1, and that the task number is no more than the number of tasks we have within our list. So if this condition is met, the task number is going to take a -1. Remember, the reason we're taking a -1 is that the index of Python starts from 0, but in this case we want to start by 1. So for the particular number, we're going to be going one level before, just to do that, and I'm going to set the completed to true. Remember that when you add, it's going to set the completed as false. The moment it is completed, it's going to set that to true, and I'm going to print this to tell you that the task has been marked as completed. If there are no tasks, I'm going to tell you that this is invalid task number. So if this condition is not met, this is going to return to tell you that this is an invalid task number. The final one we're going to do is to delete a task. So this should be pretty easy. Delete a task, and we'll call the function delete task. It's going to take in two parameters as well, taking the task and also taking the task number. Again, I'm going to be making sure there's a valid task that I'm going to be deleting, setting the same condition that I set on the completing of the task. And afterwards, the task number again, -1, because the index we need to go one level before. And I'm going to be using the pop function just to take it out. And I'm going to be printing that afterwards to tell you that I have completed this. And if there is none, the condition is not met, there's no valid task number, this is just going to show invalid task number. And I think I have all the functions that I need for what I'm doing. The next step will be to create the main. The main is like the orchestrator where I'm going to perform everything, bringing everything together. So within my main, I'm going to be importing the functions from the to-do functions module. And the module I've created this module already. I'm just going to be importing all of the functions. So I'll just import to-do functions and give it an alias as to-do. I'll create a function so that all of my menu can be displayed when the user runs the code. And I'm going to use define display underscore menu. First thing I'm going to print the new line command. I'll create a new line to say to-do list application. Then afterwards, I'm going to print 1 view task, print 2 add a task. Oh, sorry, I didn't have this thing. 2 add a task, 3 complete a task, and print 4 delete a task, and 5 I'm going to print exit. Okay, so how do we handle all of this? And this is just here, it's not going to do anything. What is going to help it do something is the conditions I'm going to set. Now I'm going to be tying everything up together, like bringing in all of the functions and attaching them to each of the different commands that I'm going to have in the display, because I'll allow the user to enter either of this number, either a 1 to view a task, a 2 to add a new task, 3 to complete, 4 to delete, or 5 to exit. And to do that, I'm going to be creating a new function. I'm going to call it handle choices, or just handle choice, because the users are going to come with different choices from above when they display that. And so I'm going to be taking in a parameter for choice and a parameter for task. So if the choice of the user is 1, what you should do is I'm going to assign 1 to display. So it's going to be to-do.display. Remember that this display is a function from my to-do module that I created in the to-do functions module. So I'm going to call this function now and say to-do. This is display task. Yeah. And it's going to take in the parameter task. If you remember what we said about elif, I'm going to use elif. If the choice is 2, set a new parameter and I'll allow the user to enter the title. Call this enter the task title. And when I'm done, I will call my function to add. It's just showing here already. Add task, taking 2 parameters, task and title. elif again. And if the user choice is 3, just complete this. Yeah. So I'm going to use 3 to complete the task. So what I want the user to input an integer or a whole number, and you input the particular number of the task. And when you input that, I'm going to call the function complete task, and I'm going to complete that particular task. elif, if the choice of the user is 4, if the choice is 4, the user is going to input the task he wants to delete, and I'm going to call the function to delete, and I'm going to delete the particular task, taking 2 parameters, the task and the task number. elif, if the choice is 5, I'm going to be saving the task. Of course, 5 here is exit, and once you say you want to exit, that's when I'm going to save the task, and I'm going to save it to my JSON file. And after that, I'm going to say goodbye and return false. Finally, else, I'm going to print. So if none of these conditions are met, I'm just going to say invalid choice, please select a valid option. And after that, I'm going to return true. One final step, we are now going to run the main program. I'll say main program loop. This will going to be the main program loop. If the name of the program being run is not, if the file being run is not the main file. Here, I only want to run the main file when it's being run from the file. If this file is being imported as a module, I don't want this main to run. I only want it to run when it's being run from the file itself. And that is why I'm putting this condition. So if the name is going to be the main, the task is going to load the task, and I'm going to see all of the options, and it's going to print welcome to to-do list application. So why this is true, I'm going to display the menu. using this function I've created. I'm going to display the menu and allow the user to enter a choice of the number, and I'm going to call this function and run this. But if this doesn't run, just break the loop. Let's test this and see what we could come up with. I think this should be fine. I'm going to run this. You can see the output. It tells me view task, add a task, complete a task, delete a task. What is actually displaying this at this point is the display menu is actually displaying all of this, and at the same time my load task is running. So I'm going to run this and I'm going to choose to add a task. I'm going to say 2, add a new task, and I say subscribe to Data with David. Good. It shows me that task subscribe to Data with David was added, and I could view the task and I can say 1 view task. When I say view task, it shows me the task. Let me just increase this. Say view task, it shows me subscribe to Data with David has not been closed, and I could just say complete task using 3. If I say complete task, it asks me for the task number, is the first one, and it shows task marked as complete. If I view all of the tasks again, it shows me that this is only one task I have, and it checks this out to say that this has been completed. So I'm going to exit, and to exit it saves this. So if I click on 5, exit, this is saved. If you see what happened immediately, I have my JSON file that has been created. So everything is going to be saved in JSON, and the JSON acts as my database, keeping in all of the file that I have here, and it goes into the JSON file. If I want to run this again, I could run this and say, let me view all of the tasks. I view the task and I want to delete. I could use 4, and I have my task deleted. Enter the number, I have 1, delete. Subscribe to David has been deleted. If I do view task again, it shows me no task available. So you could try this on your own and see how that goes. However, there are some modifications you can also do to take this further. And one of the things you can use is to develop a graphical interface for this for improved user experience. See how you could work around that. And you could also implement categories and priority levels for tasks, set up different priority level using the task. And you could also, like I said, put in the database, store that task in a database for enhanced data management. See how you could use any kind of database you want to use for this, Oracle DB, Microsoft DB. Just try your hands on it and see how you can go. One thing you will see that was omitted in my task is that I didn't put any kind of error handling when we talked about the try and accept. You could wrap critical code in try and accept blocks to handle file read and write errors or invalid user input gracefully. And these are few enhancements and modifications you could make. You can copy the code. I'm going to be putting this code in my description. Download the code, try this out and see what you could come up with. And for the second project, we are going to be doing CSV Data Pipeline Simulation. The CSV Data Pipeline Simulation project is a basic ETL pipeline. So the extract, you transform, you load. We're going to extract data from a CSV file to perform cleaning and transformation and save the process data in CSV and JSON format. So that's going to be our output. This project is just to simulate the core engineering tasks like extraction, transformation, cleaning, and putting the data into different formats. Like we're going to be doing, we're not going to be connecting to any database. We're just going to be doing everything within our environment. Don't forget, this is a simulation, just to show you how you can do that in a more larger environment and organization, because you'll have more advanced tools. You could use different applications you could work with, Azure Data Lake, different kind of storage, S3 bucket. All of this you could also implement the same thing, but just understand the core process of data transformation. And I'm going to be going to my environment, and in my day 15, I'm going to create a new directory, and I'm going to call this data pipeline just as simulation. Oh, great. Within my data pipeline simulation, I have a file. This is just a sample file that I'm going to be using. It's a CSV file, and the file has these columns. It has the date, the employee ID, auditor ID, total tasks, samples, defect, fatal errors. And this is just a sample data that I've used in the past, and I'm going to be using this. You could use any data in CSV for this. And after that, I'm going to be creating the first file. The first file is going to call the extract. So I'm going to extract the data from this particular input file. I'm going to create a second one called the transform. You extract, then you transform. Then the next one is to load. After loading, I'm going to now create the main where I'm going to orchestrate everything. So let's go to the extract. For the extract, I'm going to be using pandas, and I'm going to import pandas as PD. After that, I'm now going to extract, create a function to do the extracting, and the extracting is going to take a parameter of the file path. So I'm going to choose the particular file path I'm going to be extracting from. In this, I'm going to be putting it in a try and except block, so I'm just going to go straight to it. I'm going to say try data will be pd.read read CSV. There's a pandas function just for you to be aware. So I'm going to read the file path, and after that I'm going to print data extraction successful. Afterwards, I'm going to return the data. I'll try that. If there's an exception, I'll create the except block. Maybe file not found error, which is typical for this. What I want to print is print error. The file was not found, and I'll just go on to return none. Sorry, none. I think I'm comfortable with this one, and I could go to the next. I'm going to open my transform. After extracting, we can now transform. Again, in transform, I'll also need pandas. Import pandas as PD. In case you're having problem importing pandas, maybe you're getting an error, you could watch the previous video where we talked about installing external modules within PyCharm, and it's going to be of help. Transform function to clean the data. Create a function, I'll call it clean data. I'll create a parameter, I'll call it clean data. So the .drop NA is going to remove any missing value in my data frame. And when I'm done, it's just to clean that. I'm going to print data cleaning successful. Maybe just to specify that is the missing values that was removed. Of course, I'm getting an error. I'm just going to put this in a double quotation, and I'll return the clean data. The next function I'll be creating is to transform function to perform simple transformation. So give a function, define the function, give it a title. The title is going to be transform data, taking the parameter of the data. So let's start. You could add as much as you want here in the transformation you want to do. Because this is a demo, I'm just going to be doing like a very, very little transformation, mainly the date, and you could do other transformation as you want. You could just add them within your project. So if the date in data.columns, so if there is date in all of the columns, you should do something to the date. So data, you should put it in date time, and this is my data date. Put it in datetime format. You could do other transformation to your date, but I'm going to stop here and just print and say date transformation successful. So I'm going to be stopping in just these two transformations, and you could do other transformation, you could do aggregation, you could do a couple of more transformation based on your use case. I will stop here now and go to my load. So after you extract, you transform, you can now load. And this is where I'm going to specify all of the output files that I'm going to be using. For load, I'm going to import my OS, and I'm also going to import JSON. And after that, I can now say load function to save data back to CSV. I'll define the function called load data to CSV. And I'm going to take two parameters, data and the output file. data to CSV. I will use the to CSV function. The CSV function taking parameters, and it's going to be the output file. I'm going to index as false. So on the load, for the first one, we're going to import all of the different packages we'll be using, and I'm going to create the function to load, and the function is going to call two parameters, data and the output file. The output file is the final location where this is going to go to, and I'm going to use the to CSV function to write this to CSV. And this index false is just because I don't want to write the index alongside the data. I just want only the data to be written. And after that, I'm going to print that this has been successful. Remember, initially I said we were going to be writing to two file formats, to CSV and to JSON. And I've just written this now for us to be able to write it to JSON. And for the JSON one, I'm going to call the data, take the parameter of the data and the output file. I'm going to write to JSON the output file. However, I have this here, the orient equal to records and the lines equal to true. For the orient equal to record, what it does is that this parameter specifies the format in which the JSON is written. And so in this case, I'm setting to records. When set to record, each row in the data frame that I have is converted to JSON object. That is a dictionary having the key value pair. And all these dictionaries are put into a list. And also for the lines equal to true, when this is set to true, the JSON output is written in a line delimited format, meaning each record and each of those rows is written on a separate line. This is very, very useful if you're processing large data set because you can redefine one line at a time. And so I have that off the way, and the final piece I'm going to put together is going to be on the main. Don't forget, the main is my orchestrator. That's where I do everything. I'm going to import all of the different modules that I'm going to be using, the extract, the transform, and the load, which I have created. And I'm going to set the main function. The main function is going to list different parameters, the input file, put the name of the input file, output file cleaned, and output file cleaned as well. Clean data for JSON, clean data for CSV. So I'm going to extract. This is going to call the function extract data, taking in the parameter that is here already. The input data is the name that I have here for my input data, and that's the input file. And when I'm done, it's going to go over the cleaning of the data. But first, I'm going to put a condition. Only do this if data is not none. And I call the function to clean data. I do the cleaning. I call the function to transform. Like I said previously, you could have more functions to do much more transformation within your data. And after that, I'm going to load the data. I'm going to load the first as the CSV, and I'm going to also load it as the JSON. And mind you, in my function, when I was creating them, if this data don't exist, the output file is going to create the data. And if this doesn't exist as well, it's going to create that. And I'm going to put this condition, just like what I explained previously, to ensure that this is only run from the notebook itself. And if I should run this, when I run this, I'm getting a slight error, and I think this error might be coming from the to CSV, the load part. And when I look at this, everything seemed to be good, maybe from the transformation, because this is only going to do to CSV if I'm actually returning a data frame. Yeah, so this should actually return my data. Let's go and try again. Well, I'm still getting the same error. Let me see again. Now transform. Let me see again. Okay, they should actually, the indentation is wrong. Just move that back. Let's run this. They should work now. Yeah, it tells me that the data extraction is successful. Data cleaning successful. Missing values removed. Loaded this and completed. You can see that the two files has been created. I have my CSV and I have my JSON file created. And also you can see that in the clean CSV is here. To sort of round up, the tools that we've used for this is the Python, the pandas, the CSV, and the JSON libraries for file reading and writing. And for the enhancement you can do to this, like the previous one, you can perform your database integration, load the transform data into an SQL database for scalable storage. You can also use automated scheduling, because most of data engineering tasks is on automation, so it can schedule your pipeline. You can also add the login to monitor pipeline processing and errors. Also handling try and accept, you could use that on other code I didn't implement the try and accept. like the missing files or invalid data types for more robust pipeline, and a couple of more things you could figure out along the way. Thank you for watching. It's been an incredible journey and I want you to go on and try this out. I hope this has been an incredible 15 days of Python. Subscribe, like my YouTube channel and share with everyone so that they can also have access to this information. Thank you for watching. Bye for now.